This is lesson 1.2. In this lesson, we're going to be diving a little bit deeper into the world of radicals. We're going to be doing a couple things. Number one, we're going to be learning how to mentally calculate some of the easier numbers when it comes to radicals. And then we're going to be learning how to plug things into our calculators. And then we'll finish off with a couple algebraic properties of radicals. In other words, learning how to simplify radicals or factor them just like you would with the algebra that you're already used to doing. Okay, so let's jump right in. As a recap from lesson 1.1, we talked about square roots and cube roots. Now remember that all positive numbers have two square roots, and this word positive is very, very important. Okay, we cannot, I'm going to stress this again, I did in lesson 1.1, but we cannot take, whoops, my writing is a little messy today. We cannot take the square root of a negative number. Okay, remember what the square root means. It means what number multiplied by itself gives you whatever is on the inside of the radical sign. Okay, so and whenever you square a number, you're never going to get a negative. So you cannot take the square root of a negative number. Okay, that's really, really key. And so, but every positive number has two square roots. One of them positive, one of them negative. But whenever we use this little symbol here, this little square root symbol, that denotes what's called the principal square root, and so that's only the positive answer. So when I say the square root of 16, I know 16 has two square roots, 4 and negative 4, because when you square either of them, you get 16. But we just consider the principal square root, which is 4. We usually just take the positive answer. Okay. Now with cube roots, though, you don't have to worry about this whole positive, negative game. Okay, you can take the cube root of a positive and a negative number, and you're going to get an answer. Okay, so for example, the cube root of 1000, what does that mean? It means what number multiplied by itself 3 times gives you 1000, and the answer to that is 10. Okay, similarly, what number multiplied by itself 3 times gives you negative 27? The answer is negative 3. Okay. And if you don't have a perfect square, if you don't have a perfect cube, then when you take the square root and the cube root, you're going to get an irrational number, so some messy decimal. For example, here, cube root of 49. If I plug that into the calculator, which, well, let me get rid of this stuff. I'm going to be showing you how to use the graphing calculator a lot as we go. But if I want to access the cube root, I have to go over here to math. And then the cube root is option 4 here. Okay, so I'm going to hit option 4. And it was the cube root of, what did they say it was? 49. So, whoops, I'm going to go over here to my calculator. I have the cube root of 49, and I hit enter. Since 49 is not a perfect cube, you get some irrational, messy decimal right there. Okay, that's what they're saying here. So here we go. Let's kind of branch away from just square roots and cube roots. We're going to go beyond that into 4th roots, 5th roots, 6th roots, etc., etc. But let's start with the small stuff. 4 times 4 is 16. So the square root of 16 is 4. It goes backwards, right? If 4 squared is 16, then the square root of 16 is 4. Whoops, that's my highlighter. Let me get my pen. There we go. 5 cubed, which is 5 times 5 times 5, is 125. So if we want to go backwards, the cube root is 5. Okay, and we write that like this as well. The cube root of 125 is 5. 4 copies of 2. That means 2 to the power of 4 is 16. So the 4th root of 16 is 2. Okay, and we can write it like that as well, the 4th root of 16. Okay, how many copies of 10 do we have here? 6. So this means 10 to the power of 6 is 1,000,000. So that means that the 6th root of 1,000,000 that's going to be 10. Okay? It's literally just working backwards from the exponentials that you're already familiar with. Okay? So let's see if we can mentally evaluate, where possible, using the real number system. Okay? So if you have your perfect squares table and your perfect cubes table handy, this is going to help you a lot with that. Okay, so square root of 49, I know that 49 is a perfect square. So if I take the square root of it, what number multiplied by itself gives you 49? The answer is 7. Okay. What number multiplied by itself 3 times gives you negative 64? That's going to be negative 4. I'm pretty sure. Yeah. What number multiplied by itself 4 times gives you 10,000? Do we know that one? It's going to give you 10, right? 10 times 10 times 10 times 10 is 10,000. Now this one's an interesting one. What number multiplied by itself 5 times gives you 1 over 32? Okay, so I'm actually going to go to the calculator for that one. And I'm going to go, now to get the 5th root, I'm going to hit 5 first, and then I'm going to go over to math, and I'm going to hit this option here, option 5. If I do that, then it's going to give me the 5th root. Okay, and then on the inside, I'm going to write 1 divided by 32. And I'm going to hit enter. It's going to give me 0.5, which if I go to math again, if I want to express my answer as a fraction, I'm going to hit option 1. And it's a half, obviously. Okay, so this apparently equals 1 over 2, which is interesting because the 5th root of 1 is 1, and the 5th root of 32 is 2. So it almost appears as if we can take the 5th root and apply it to the numerator and the denominator separately. Okay, and that's going to be something that we're going to look at a little bit later on as well. The next one, the 4th root of negative 16. Now I'll let you wrestle with this one for a little while, but try to convince yourself that this one is actually not possible. Okay, so in class, I'm going to ask you guys this. Why is this one not possible? Okay, so try to come up with a reasonable answer to that. The next one here, this is 2 multiplied by the cube root of 125. So this is going to be 2, and then it's going to be multiplied by, now the cube root of 125 is 5, because 5 cubed is 125. So this is 2 times 5, which gives you 10. All right, so let's go on to the next page. I've already kind of shown you how to use the calculator, but the instructions are here. It walks you through it. Whatever root you want, you have to press that number first. Then you go to math, you choose option 5, and then you type in the number that you want to take that root of, and it'll pop out the answer for you. So let's give a little bit of practice to these ones. Okay, so we want the 5th root of 1024. So let's go to the calculator, clear this. I have to type 5 first, go to math, option 5. That gives me the 5th root of, and then I want 1024. And that's going to give me a nice 4. Okay. Now here we go. The 7th root of negative 2187. Let's see if we can do that one. Oh, come on. There we go. All right, so I can clear this. I have to do the 7th root, so I'm going to hit 7, math, option 5. The 7th root of negative, and what was the number? 2187. 2187. Hit enter, and that's going to give me negative 3. So apparently negative 3 to the power of 7 gives me negative 2187. Okay, so go ahead and do the next one, and the one after, obviously. And you should get, this one, you should get negative 45, so make sure that you can actually get that on your calculator. And this last one here, if you were to type it into your calculator, you're going to get 1.2. Okay. Now, I'm going to show you something here. If I type, oh, come on, calculator. There we go. If I type 1.2, and then I want to express that as a fraction. So I'm going to go to math, and I'm going to hit option 1, which is my fraction option. I'm going to get 6 over 5. So I'm going to write that down. But then we're going to notice something that's kind of interesting. This is equal to the cube root of 216 divided by the cube root of 125. The cube root of 216 is 6, and the cube root of 125 is 5. So it seems like whatever root you're taking, if you have a fraction, you can split it up in the numerator and denominator, and you can apply the radical, or the root rather, of each one separately. Okay, so that's going to be some of the algebraic properties that we're going to see later on. All right, so I'll let you do these ones by yourself. Double check with my answers on if you type it into the calculator to the nearest hundredth. This one you should get approximately 2.63. The next one you're going to get 0.89, and the last one is 2/3 times the 4th root of 1,000. That's going to be 3.75. So make sure you can actually get those numbers on your calculator to know that you're doing it correctly. Okay. So let's go over some vocabulary. Okay. So we have this radical here, and we have a couple different vocabulary words to indicate different things. Okay. So this is, in this case, this is the cube root. Okay, that cube root, we have a special name for it. It's called the index. Okay, whatever's on the inside, we call that the radicand. Okay, and then the actual radical sign is the fancy little check mark looking symbol that we have here. Okay, and putting that all together, if you want to refer to the entire object, we call that the radical. But then you have these individual pieces of the radical, the index and the radicand. Okay. And a couple notes here. Whenever we don't, and you've probably noticed this already, whenever the index is not written, you're going to assume that the index is 2. So for example, if I write this indicates that it's the square root of 71. So there's really an invisible 2 here. Okay, but we don't usually write the 2 there. Okay, it's just implied that it's the square root. The second point says the index is the number of times the radical must be multiplied by itself to equal the radicand. Okay, so in other words, what number multiplied by itself however many times gives you the radicand. Okay, and we're going to be looking at examples of that later on as well. So let's go over to the last page here. Let's see if we can identify the index and the radicand. So this first one, the index is 5, and the radicand is the inside, which is going to be 75. Here there's no index, so I'm going to assume that it's the square root, so the index is 2. Radicand is 50. Now here, you got to be careful. This 5 right here is a bit of a distraction, right? This is actually, think about this as a coefficient. The index is actually 3. And the radicand is whatever's on the inside of the radical sign, which is going to be the negative 1 over 10. Okay? So, when you did question 10 from homework lesson 1.1, you noticed that you were able to split up these radicals, right? Or combine them. So if we had the square root of 9 times the square root of 4, you could actually kind of squish them together under one long radical sign. And that becomes the square root of 9 times 4, okay? And you can work out the numbers yourself. Actually, we can do that right now. The square root of 9 is 3. and the square root of 4 is 2. So we should get 3 times 2, which is 6. Right? But if we do this guy, this is the square root of, well, 9 times 4 is 36, and the square root of 36 is 6. So these two things are equal. So when it comes to multiplication, you can either split radicals up or you can combine them together. Okay, but notice that you cannot do the same thing with addition, right? If I have the square root of 9 plus the square root of 4, that is not the same as the square root of 9 plus 4. You cannot just combine them if there's addition or subtraction, okay? But if it's multiplication and division, you can totally squish them together or break them apart. Not so with addition and subtraction. So that's what all these bold words are basically saying, okay? And in general, if you want a formula, for those of you who like formulas, if I have two radicals, square root of a times the square root of b, then I can combine them into the square root of a times b. And vice versa too, right? I could break them apart. Similarly with division. If I'm dividing two radicals, then I can bring them under one roof, I like to say. Okay? But notice that both of these are square roots, right? If this was a square root and a cube root, you can't do that. They have to be the same index. That's the rule. Okay? So I'm actually going to write that down. So in order to do this, you need the same index. Okay. So let's see a couple of examples here. State whether each statement is true or false. Okay. So root 3 times root 6. Well, according to this green formula, I can combine it into root 3 times 8. 3 times 6. Excuse me. But 3 times 6 is 18. So this one is definitely true. Okay. The square root of 20 divided by the square root of 10. Well, because they're both square roots, I can do 20 divided by 10, which is the square root of 2. So this one is definitely true. However, look at this one. This one has a plus sign in between the two numbers, and they're splitting them up. So this one is falling under the category of right here, where I'm kind of hovering my mouse. So this one is definitely false. If it's addition or subtraction, you cannot do this. This whole splitting up or combining game. You can only do that with multiplication and division. So let's take a look at these examples here. Root 8 times root 3. We want to write them as a single radical. So if I want to do that, then this is going to be the square root of 8 times 3, which is going to be root 24. Okay. Well, this one, I mean, everything's on the inside already, so this is just going to be the square root of 21. This one is going to be the square root of 50 divided by 10, which is the square root of 50 divided by 10 is 5. Okay. And this last one, okay, there's a square root inside a square root. So let me simplify the inside of the numerator first. This is going to be the square root of, now the square root of 100 is 10. So really I have the square root of 10 over the square root of 2, which if I applied the blue formula up here, then that's going to be the square root of 10 divided by 2, which is 5. Okay, see how that works? All right, last couple examples here, and then we'll call it a day. Express as a product of radicals. Okay, so now we're doing the opposite. So instead of combining them, we're splitting them up. Right? So you have to think, okay, what are the factors of 77 in this case? Well, I could split up 77 into 7 times 11. So this is equal to the square root of 7 times the square root of 11. Okay. Root 27, I could split that up into root, what about root 9 and root 3? Okay. I don't really have to write down the multiplication sign. If you have two radicals beside each other like this, then multiplication is implied. This one could be root 4 times root 10. Or it could be root 2 times root 20. Or it could be root 8 times root 5. Right? There's actually multiple possibilities for this last one because 40 has a lot of different factors. Okay, so all of these are the same. If you don't believe me, plug it into your calculator and verify for yourself that all of these are actually the same. Okay? All right, well, that does it for lesson 1.2. We'll see you next time.